Nearly every signal Voyager 1 sends to Earth begins an extraordinary journey. Traveling at the speed of light, the radio transmission spends almost an entire day crossing more than 24 billion kilometers before finally reaching NASA's Deep Space Network. By the time scientists receive that message, the spacecraft has already traveled millions of kilometers farther into interstellar space. That alone makes Voyager 1 remarkable. Launched in September 1977, the spacecraft was built for a mission expected to last only a few years. Its original goal was straightforward: explore Jupiter and Saturn, return detailed photographs and scientific measurements, then gradually fall silent as its systems aged. Instead, Voyager became one of humanity's greatest engineering achievements. After spectacular flybys of Jupiter in 1979 and Saturn in 1980, the spacecraft gained enough speed through gravitational assists to escape the planetary region entirely. Rather than ending its mission, Voyager continued traveling outward, farther than any human-made object had ever gone. Then, in 2012, history was made. Voyager 1 crossed the heliopause, the boundary where the outward pressure of the solar wind is balanced by the material filling interstellar space. Beyond this region, the Sun no longer dominates the surrounding environment. For the first time, a human-built spacecraft entered the space between the stars. Scientists expected this distant region to be extremely thin and relatively uniform. While not completely empty, interstellar space was generally thought to change slowly over vast distances. Voyager revealed something much more complicated. Its instruments detected variations in plasma density, changing magnetic fields, energetic cosmic rays, and subtle pressure waves moving through the surrounding medium. Perhaps most intriguing was a faint, continuous plasma wave signal that researchers have monitored for years. This is not an artificial radio transmission or evidence of an unknown source communicating through space. Instead, scientists believe it is produced naturally by the motion of ionized gas, called plasma, threaded through the interstellar medium. The signal acts almost like a background vibration, allowing researchers to estimate the density of the plasma surrounding the spacecraft. Before this discovery, scientists often relied on powerful solar eruptions to generate temporary disturbances that revealed the properties of interstellar plasma. Voyager demonstrated that even without these dramatic events, the surrounding medium possesses a steady level of activity. Rather than drifting through an empty void, the spacecraft is traveling through a dynamic environment filled with magnetic fields, charged particles, and constantly changing conditions. Each new measurement provides information that no telescope can collect from Earth. Voyager is not merely observing interstellar space. It is experiencing it directly. Every day, as the spacecraft moves farther from the solar system, it samples a region that remains completely inaccessible to every other active mission. Yet just as Voyager continued making these remarkable discoveries, the mission came dangerously close to ending forever. Late in 2023, engineers monitoring NASA's Voyager 1 mission noticed something deeply concerning. The spacecraft was still communicating with Earth. Radio signals continued arriving on schedule after traveling nearly an entire day across more than 24 billion kilometers of space. At first glance, everything appeared normal. But when scientists examined the incoming information, they realized something was terribly wrong. Instead of returning understandable engineering telemetry and scientific measurements, Voyager was transmitting corrupted data that could not be properly decoded. The spacecraft hadn't fallen silent, it was still talking, but its messages no longer made sense. Communication had survived. Understanding had not. For one of the most important scientific missions in history, this was an alarming moment. Voyager 1 is humanity's most distant spacecraft, and every piece of information it sends represents a unique glimpse into a region of space that no other active mission has ever explored. Repairing the problem, however, was unlike fixing any ordinary spacecraft. Voyager 1 is so far from Earth that every radio command takes roughly 23 hours to reach it. Once the spacecraft receives that command, another 23 hours are required before its response arrives back on Earth. Even the smallest troubleshooting step can consume nearly 2 full days. There are no emergency repairs. No quick software updates. No astronauts can visit the spacecraft. Every decision must be carefully planned, tested, transmitted, and patiently awaited across billions of kilometers of empty space. After months of detailed analysis, NASA engineers finally traced the malfunction to the spacecraft's flight data system. A small section of memory responsible for storing critical software instructions had become corrupted, preventing Voyager from correctly organizing and transmitting the scientific information collected by its instruments. The failure was caused by an area of memory that could no longer reliably store the data required for normal operations. While the spacecraft itself remained healthy, its voice had become scrambled. Replacing damaged hardware was impossible. Instead, engineers accomplished something extraordinary. Working with computer systems designed in the early 1970s, they developed an entirely new software strategy. The damaged code was carefully separated into smaller sections and relocated into healthy portions of Voyager's remaining memory. Every instruction had to fit within the spacecraft's extremely limited computing resources while maintaining compatibility with hardware nearly half a century old. It was, in many ways, like performing remote brain surgery on a spacecraft more than 24 billion kilometers away. Every modification required weeks of planning. Every command had only one opportunity to succeed. A single mistake could permanently end the mission. Then, after months of anticipation, the impossible happened. In 2024, Voyager 1 once again began returning readable engineering telemetry. Mission controllers confirmed that vital spacecraft systems were operating correctly. Soon afterward, one scientific instrument after another resumed sending valuable observations from interstellar space. For the first time in months, humanity's most distant explorer was fully speaking again. Among the restored measurements were observations from Voyager's plasma wave instrument, magnetometer, and cosmic ray detectors, 3 instruments that continue providing scientists with information unavailable from anywhere else in the solar system. The plasma wave instrument measures the extremely thin ionized gas filling interstellar space, allowing researchers to estimate the density of material between the stars. The magnetometer records changes in the surrounding magnetic field, revealing how our Sun's magnetic influence interacts with the much larger magnetic environment of the Milky Way. Meanwhile, the cosmic ray detectors monitor energetic particles arriving from distant supernovae and other powerful events occurring throughout our galaxy. Together, these instruments are gradually building humanity's very first direct map of the environment separating the stars. Every new transmission expands our understanding of a region that had existed only in theory before Voyager crossed the heliopause in 2012. Yet time is becoming increasingly precious. Voyager's electricity comes from radioisotope thermoelectric generators powered by the natural decay of plutonium. These generators have supplied reliable electricity for decades, but their output slowly decreases each year. To conserve the remaining power, mission engineers have already switched off several scientific instruments that are no longer considered essential. As the years pass, additional systems will eventually need to be shut down, one by one. Despite these sacrifices, the mission continues producing discoveries that cannot be obtained any other way. Sometime during the coming years, however, Voyager will eventually lose the ability to power its remaining instruments and maintain communication with Earth. When that final transmission arrives, the spacecraft will not stop traveling.